5-6, Part 2, we're looking at reflections. We can reflect across the x-axis, and if we do that, the x value of our points do not change. So the x-axis right here acts just like a mirror, and so if we take this point here, which is 1, 2, and we reflect it down, that just means bring it down to the line, and then keep going down the same amount on the other side, you get your pre-image. This point would be at 1, 2, and the image or reflection would be at the point 1, -2. So notice the x stayed the same and the y changed. And so this other point of this line is -2, 3. If I reflect that down through the x-axis, I'm going to end up with -2, -3. The x stayed the same and the y's changed because I went from above the x-axis to below. And I have this written out here. Our general rule when we are reflecting across the x-axis is if we have a point xy, when we reflect it, x stays the same, but y is going to change sign because it's going to be multiplied by -1. Now if we can go across the x-axis, we can do the same thing across the y-axis. And so in this time we use the y-axis as the mirror. And so we have -2, 3 here, and when we reflect it across the y-axis, we're going to go from -2, 3, and we're going to end up at 2, 3. And then we're going to do the same thing here, -4, 1, we reflect it across, we end up with 4, 1. So notice here, the y stay the same, and the x's change. So we have our -2 to +2, 3 stay the same, -4 to +4, 1 stay the same. So our general rule for our y-axis is if we have a point xy, when we reflect it, the x changes sign, x times -1, and the y stays the same. So I want you to pause and go ahead and complete page 200. Now our last type of transformation here that we're going to do, translation, is a rotation. Now the rotation is slightly different, and it's either going to be much easier for you or a little more challenging for you to visualize. And in a rotation, we don't have this nice simple rule that we had for our reflections and our translations where we just add, and our scale factors where we multiplied. For a rotation, we have to look at the whole figure. So it's really helpful, and your book recommends that you do, and I do too, cut out a piece of paper then the same size as your triangle or whatever image you're moving, so you can actually take it and move it around on the paper. If I have this black triangle as my pre-image, I have a point at 5, 0 down here, a point at 5, 5. Now if I want to rotate this counterclockwise by 90 degrees, that means I'm going to take this whole triangle, and I'm rotating this about the origin. I'm going to take this whole triangle, I'm going to leave that point at the origin, and I'm just going to turn. And so this point here rotates until it's up on the axis. This point here rotates until he's over here. And so this is a 90-degree rotation. You can see where this first line starts and where that line ends is a 90-degree. So once I rotate it, that 5, 0 point becomes 0, 5. The 5, 5 point becomes -5, 5. And the origin, which didn't move, or which is where we were rotated around, doesn't move. So 0, 0 stays 0, 0. An example, if I have this black pre-image here, I have 0, 0, 2, 2, 5, 0. And if I want to rotate this one 90 degrees clockwise, so the way that a clock moves, about the origin, we're going to keep the origin the same. This stays still. And we think about rotating it sideways. And when we do this, this point 5, 0 rotates down onto the line, becoming 0, -5. And this point 2, 2, when it rotates down, ends up at 2, -2. So I want you to try to attempt those problems on page 202, and we're going to talk about this in class.